protect yourself online, you can, of course, have some kind of software to actually protect you. There are different kinds of software like that. We have, for example, antivirus, anti-spyware, anti-spyware. Now, if you're using online, of course, you're using some kind of online services like email and etc. They would have an embedded antivirus software. They would have anti-spam, right? So all of these software work differently. For example, what we are going to talk about now is how antivirus works. Antivirus basically, it will do this thing. It's called the checksum. Check what? Checksum, right? A checksum. What is that? Basically, a program will contain a certain number of bytes, right? It's definite. It shouldn't change, even if it's an interactive program, right? It will have some kind of control of over its interactiveness. For example, if this program actually asks you some kind of input, and that input is actually used in the next instruction, right? It will still have some kind of degree of control, meaning it would have a set number of bytes. So the antivirus software will actually know this sum of bytes, right? And so if a certain people actually, let's imagine this is your program. Imagine this is your program, right? And some bad people just erases this part of it and put his bad programs inside, right? So the black lines are your original program, and some bad people just erases it and put these red lines, which are supposedly bad programming, right? Malicious software, malicious codes, right? So the antivirus will go through the program and see, hey, there's a change in the number of bytes. So they perform what we call the checksum, right? We check the sum of bytes, right? So once they know that, then they know that once they discover the sum is different, then they know that there's something wrong, and then they can check thoroughly, right? Other than that, they can also look for virus signature. A virus signature is, you can say, a behavior of a virus, usually reflected through the number of bytes and a certain pattern of bits, right? Certain pattern of binary numbers. This pattern is what kind of virus. So this is usually for famous viruses, and so they will have what we call um, update of virus signatures, meaning every now and then you'll notice that your antivirus software will have updating of its virus signature every now and then, database of virus signatures, right? Now, so these are just software that you might get online, meaning protection that you can actually get, right? Spam filter from your email, for example, right? Anti-spyware to get rid of phishing, right? So with anti-spyware you can get rid of phishing, right? Phishing, anti-spam or spam filter, right? And aside from all of these tools that you can download and install or buy and install to protect you, you can also protect yourself. For example, you can tell children not to spend too much time on internet and not to reveal their personal information. You can not reply spam or not click on spam. You can not click on attachments from emails that you do not know. You can set strong passwords. Yes. One more thing is the firewall that we covered here. Firewall is another type of protection, which is, you can say, third party, meaning it's done by a software or hardware, right? Whereas you can also make decisions to actually protect yourself. You can create secure passwords. For example, it must be long. Right? Rules for a secure password, it must be long, right? It must be a combination of stuffs, combination of alphabets, right? Numbers, symbols, and caps. Caps is basically alphabet. Caps is basically alphabet, right? meaning you can use capital letters and small cap letters for your password, right? And if possible, create a password from a nonsensical word, right? Let's say you want to create a password named anti-spyware, right? Anti-spyware is it has a decent length. It's 11 characters long. But if you just create it like that, hackers can do this attack. It's called the dictionary attack. Dictionary attack is where a hacker has this dictionary of commonly used passwords and all the words that is available in a dictionary. So the program basically just runs through and guess the password one by one through what is inside the dictionary, right? So if you use a word which is common, even if it's long, it is still very much guessable. So instead of doing this, instead of anti-spyware like this, you can, for example, change the A to at, right? And instead of I, you can use exclamation mark, right? Or number one. And instead of S, you can use dollar sign, right? So here, and then you combine it where like that, right? So anti-spyware. Here you're making a rather secure password for yourself. It's long, meaning it's more than eight characters long, right? And you combine these things. Now it's harder for the hacker to actually guess your password. Okay, another type of safety measure available online is what we call encryption. So basically we have our alphabets, right? We have our alphabets A, B, C, and etc. A, B, C, D, for example. Now, instead of using A, B, C like that, you can actually use a representation of A, B, C. Let's see, for A you use 1, for B you use 2, for C you use 3, for D you use 4. It's pretty simple like that, right? Now, if you do this, you can actually send a message using numbers, right? For example, you want to say you want to say ABC. For whatever reasons you want to say ABC. Easy as ABC, right? So you just put 1, 2, 3 like that. And so this, instead of the regular text that we can actually read, right? You're now encrypting it, right? So this process is called encryption. Right? So encrypt into this. Of course, the reason for you to encrypt it is so that even if people get your message, they will not be able to read it if they do not know this. And so what does we call this? What do we call this? We call this the encryption key. Right? So this whole thing is called the encryption key. Meaning is like a chart that actually tells you how to change from one point to another. Right? So the person that should have the key is the intended recipient. For example, if you're sending this message to, let's say, Mr. Siva, right? So Mr. Siva will have this key. And so once Mr. Siva gets this, he will use the key to decrypt, right? And so the message will then become ABC, right? So this is encryption and decryption. Encryption is you jumble up message into a form that people cannot easily understand. Decryption is where you reform or rearrange the message back to its original form, right? And to be able to do this, you need an encryption key. And this whole study of encryption and decryption and encryption key and how to jumble up messages are called cryptography. And people who are well versed in cryptography is called cryptographer. Right? So the person who knows this, let's put this as a dialogue like that. Right? Right? So this guy is called cryptographer. So this is the whole cryptographer thing where basically you can jumble that message. Now, this is of course again something that is created with a lot of good in mind, meaning we create it so that our messages can be clear because there's so many threats. But then again, what happens if the guy who has this key and is using all of this encryption and decryption, meaning the client to this guy, right? So I'm your client, for example. So this guy is the client. Client, right? Not really clear, but he's the client, right? So I want to use the encryption. What for? Something you just got some work I gotta reveal to you, right? So that work happens to be I wanna bomb someone's toilet, for example. Okay, now this guy wants to bomb someone's toilet and he needs an accomplice to do that. So he gets an accomplice. The name of the accomplice is Draco, because Draco happens to be like a Batman's name, right? So client and Draco, C and D, right, wants to bomb someone's toilet, right? So they are sending messages to each other using some kind of encryption, and this is about the only proof that any kind of prosecution team, that the good guys, like police and prosecutors, can actually catch them and um, say they're actually committing a crime, prove that they're committing a crime by way of these messages. These are the only proof. So now we have a dilemma of whether or not we can actually see these things, because what happens that these are on personal devices and they are already jumbled up and we are not able to understand what they mean, right? So there is this thing called e-discovery, where if and when you are somewhat under a lawsuit, meaning people are actually um, alleging that you committed a crime, right? And you might have done it by way of planning using some kind of encrypted code and electronic devices, right? So people are under these lawsuits are subject to actually reveal whatever information they have, right? So this is called e-discovery, where the law enforcement can actually get information from you. So there is a bit of a debate on this, because law enforcement and governments are saying we should have right to information, whereas people are saying we should have right to privacy. So there is a bit of a debate where we need to find a balance where people can get privacy, whereas the government and law enforcement can enforce the law properly and effectively.